Hello students, good morning all of you. At the last turn, we have discussed about Cartesian coordinate system, and in which we discussed about variables, range of their variables, and differential length, differential surface, and differential volumes. And we came to know that these differential volume, differential surface, and differential lengths are nothing, but if you make a small displacement in a closed system, the volume enclosed by will be differential volume, and the surface enclosed by will be differential surface, and the length moved by is the differential length. And these differentials are very important because when we are calculating line integral, in that case differential length is helpful. And if we have to find surface integral, in that case differential surface is used, and if we have to find volume integral, in that case differential volume is being used. And these integrals are being used in different definitions throughout the course. So this was for yesterday, and today we will discuss the same thing in case of cylindrical coordinate system. And this cylindrical coordinate system, we will additionally add 2 points, that is transformation from cylindrical to Cartesian coordinate, and the relationship between cylindrical and Cartesian coordinate system. Now let's discuss cylindrical coordinate system. Let's try to find the variables in this. So first variable that we can find is the radius of the cylinder, that is considered here rho. The angular displacement of the point of interest, considering any point on the surface, that is P. The angular displacement of the point from the x-axis, that is phi, and the length of the cylinder, that is z. So in this way the coordinates can be radius, the angular displacement, and the length of the cylinder. So variables can be rho, phi, and z. So if we define rho, then we can say it is distance measured from z axis. For simplicity, we assume this measured distance from z axis. And what's about phi? Phi also have an assumption, that is angle measured from x axis in xy plane. Angle measured from x axis in xy plane. This is also termed as azimuthal angle. So keep in mind, in problems, if it comes with the name azimuthal angle, then it means they are talking about this angle. And the third is z, that is length of the cylinder. So in this way the coordinate can be represented as rho, phi, z, in terms of rho, phi, z. And if we define the range of these variables, then first variable, that is rho, can vary from, this is the reference axis, or we can say this is the 0 point. The rho can vary from 0 to infinite. This is same for full shape, so it can vary from 0 to infinite. Similarly, the angle can vary from x-axis. If you are measuring from x-axis, then the angle at this axis is 0, and as we are moving towards y-axis, in anti-clockwise direction, it completes complete cycle, so it can vary from 0 to 2 pi. And similarly, z can vary from minus infinity to infinity. So these variables can vary like this. Now the next thing, to define the unit vector. Regarding unit vector, one term that is defined here, in which direction the quantity is increasing, that is considered as positive direction of unit vector. So keep in mind, the positive direction of unit vector is considered as the direction of increasing quantity. So at this point, the three coordinates, rho is increasing in this direction. So this is a rho, this direction is a rho. Similarly, the angle is increasing in this direction, so this is a phi, and z is in this direction, so this is az. So at this point, the three vectors a rho, a phi and az are defined in the direction of increasing rho, phi and z respectively. After finding the variables and their ranges, now we are interested to find the relationship between Cartesian and cylindrical coordinate system. So now we will try to find the relationship between these two. Relationship between Cartesian and cylindrical coordinate system. And to find the relationship, we will again draw this same x, y, z in Cartesian, and in cylindrical it is p dash p. Now we have again draw the part of this cylindrical system. Now our interest is to find the rho, phi, z, these coordinates in terms of x, y and z. So this is our interest now, and to find that, we will project this at x-axis and at y-axis. This is our radius rho. This is because this is the x-axis, that is reference for the angle, so it will be phi, and this angle will be 90 minus phi. This is 90 degree and this is also 90 degree. This is our x, that is projection of this rho. Part of this in x direction will be this one. Projection of this in the direction of y will be this one. So x can be written as rho cos phi, because this is right angle triangle, this is hypotenuse, and this is base, this is perpendicular. So in that, x is equal to rho cos phi. Similarly, y can be written as base perpendicular hypotenuse. Rho cos phi will give you this, means projection of this, and this will be this cosine of this. So y will be rho cos of 90 minus phi, that will give you rho sin phi. Now square both of them and add. You will get x square plus y square will be equal to rho square plus sin square phi plus cos square phi. It will give you 1. The remaining thing will be rho, that is equal to x square plus y square. In this way you are able to find the relationship between cylindrical to Cartesian. The relationship between rho and xy is this one. Similarly, phi can be related with xy. For that, divide 1 by 2. So if you are dividing, okay, either you can divide 1 by 2 or divide 2 by 1. Divide 2 by 1, what you will get? Y by x, that is tan phi. From here you can see phi is equal to tan inverse y by x. So you are able to find rho in terms of xy, you are able to find phi in terms of x and y, and z is already in the rectangular coordinate system, so don't worry about that. Rho phi z can be in Cartesian form x square plus y square tan inverse y by x and z. So the relationship between these two can be represented like this. Now after find the relationship, we are interested to find the transformation from one coordinate system to another coordinate system. It means we are interested to find a rho, a phi, a z in terms of ax, ay and az, or vice versa. In this case, okay, so for example, we are taking first case. We have to find ax, ay and az. We can write transformation matrix and a rho, a phi, az. There is a small trick, that is not the rule but only trick. The coefficient of rho for x can be written here, that is cos phi. The coefficient of rho for y can be written here, that is sin phi. Coefficient of rho, that is sin phi for y, and the coefficient of rho for z. There is no rho, so that is 0. And to find the phi, just we have to take the d over d phi of these, that will be minus sin phi, cos phi and 0. And for z, we have to write the coefficient of z in case of x, coefficient of z in case of y, coefficient of z in case of z. In this way, we can complete our matrix that relates the Cartesian to the cylindrical. And this is an orthogonal matrix. So for that, we can write this is assumed as T, for example. for an orthogonal matrix T inverse is equal to T transpose, both are equal. So in that case, A rho, A phi and Az can be written as the transpose of this matrix. Transpose we know, rows, columns will be like this and rows will be like this. Cos phi minus sin phi and 0, this will be second column. Sin phi cos phi 0, this will be third column. 0 0 1 and it will be Ax, Ay and Az. In this way, this is the Cartesian to cylindrical, this is cylindrical to Cartesian form. After transformation, we will try to find the differential length, surface and volume in case of cylindrical coordinate system. Now for that purpose we have drawn the point of interest as it was given in the previous figure. Now we will consider the differential object by small displacement in the angle, that is d phi. This is phi, so we will make a small displacement in angle. This is very small, d phi. For clear visualization, I am taking large one. The differential object that is considered in this study, we are taking this one, and in this direction this is the differential object. The projection of this in xy plane is this one, and this is this. So in this way, this is the differential object for which we are interested to find the differential length, differential surface and differential volume. For that purpose, we are naming it A, B, C, D, E, F, G, H. This is at the boundary of the sphere, cylinder. This is at the surface of the cylinder. This is again at the surface of the cylinder. So in this way, we have this object for which we are interested to find the differential quantities. For differential length, as we discussed in the previous coordinate system, we have to move the longest displacement in this object, that is from A to A or from B to F. So to find the position vector of AE, that is AE can be written as the sum of AB plus BC plus CE. It further can be written by another route, AD DC CE, AD DF FE. We are free to choose any path, but the displacement will be same for all. So we have to choose any one. After that, AB can be. Now we have to find AB, BC, CE so that we can write the differential length. See here, this is the radius of the cylinder, that is rho, and this is d phi, the small displacement in the angular displacement. So this arc will be rho d phi if d phi is very small. In that case, this arc will be rho d phi. After that, if we relate this from here, then we find AB is this arc, that is rho d phi, and the direction of this is in the direction of A phi. So it can be written as in the rho d phi in the direction of A phi, that is equivalent to AB. Now come to BC. What's about BC? BC is nothing but part of the length of the cylinder. So part of the length, the total length is Z, the part is small length of the cylinder, that is dz, in the direction of AZ. This is in the direction of AZ direction. Now after BC, we are interested in CE. CE is part of the rho, that is differential rho. So it can be d rho in the direction of A rho. Okay, so it can be d rho in the direction of A rho. So rearranging it, we can write d rho in the direction of rho, because the standard way is rho phi z. So according to that, we will rearrange them. D rho A phi, rho d phi A phi plus dz Az. These are the differential length in this system of this differential object. Now after differential object, after finding the differential length of this object, we will try to find the differential surface. And from the previous study, we are familiar that how to find the differential surface. For that purpose, just multiply the coefficient of these two unit vectors, that is this and this, in the direction of cross product of this and this. So differential surface can be find out by multiplying rho d phi and d rho, and the cross product of this and this. And we know from the previous study, how we can find the direction of phi is tangential to the arc and tangential, and direction of rho is normal to it, and direction of z is normal to this plane. So in this way, these three are orthogonal. In that case, we can apply the product of these two unit vectors will give third one, product of these two will give this one, and the product of these two will give this one. In this way, the product of A rho and A phi will give AZ. Similarly, the product of these two d rho d phi dz in the direction of A phi and AZ, we will get A rho. And similarly, it can be written the product of these two dz d rho AZ A rho, it will give us A phi. So in this way, we are able to find the differential surface for this differential object. It can be plus and minus both. Now differential length and differential volume. And differential volume can be find out just by multiplying all the coefficients in scalar form. dV, product of this and this. So d rho, rho d phi and dz. This will be the differential volume. Rho d phi and dz. This is our differential volume. In this way, the important parameter differential length, differential surface and differential volume for this differential object in cylindrical coordinate system we are able to find. Thank you very much. This all was for today, and tomorrow we will discuss the spherical coordinate system. Thank you very much.